Hi everyone, I'm going to present our work, Mixture of Order Scoring Aspect for Cross-Prompt Essay Trait Scoring. So let me define our task first. Essay scoring means given an essay, the system outputs a holistic score to measure its overall quality. So earlier approach typically follow a prompt-specific training scheme. So that is train a separate model for each essay prompt. So when faced with an unseen prompt, this model often fails to generalize. So to address this limitation, cross-prompt essay scoring aims to develop a more generalized approach that performs well, especially on the unseen prompt. However, this study focuses on predicting a score that is one number as an output. But in real-world education setting, teachers and the students need feedback on the multi-dimension of writing, so the recent study has started to focus on the multi-trait scoring. In this setting, the system outputs not just a number, but also trait-specific scores, such as content, organization, and grammar. Building on this foundation, our work focuses on cross-prompt multi-trait essay scoring. So let's look at the motivation behind our work. Some previous work, like PIAS, only consider essay as an input. This assessment only focused on the essay quality and ignore prompt adherence. Even though Protect use LDA to extract essay prompt correlation, they only use part of speech to represent essay. This work overlook content label feature in both prompt and essay. Moreover, they develop one single label to evaluate multi-trait. It failed to capture different perspectives special for each trait. This work we propose MOOS, Mixture of Order Scoring Aspect framework for cross-prompt essay trait scoring. It includes order scorer aspect. We designed 3 aspects to imitate the reasoning process of a human writer. So when given an essay, a writer might ask, is it a good essay? Compared to other essays, is it better or worse? Given the prompt, is this essay relevant? Moreover, we include a mixture of aspect mechanism. It dynamically selects different scoring cues that are specific to each trait. It allows MOOS to adapt its scoring rubric based on what matters most for each trait. So this is the workflow of MOOS. When given an essay, we use document BERT and multi-trunk BERT to generate semantic embedding at multiple grammarities. We also extract linguistic features such as readability and word use as assigned information. These representations are used to compute trait-specific attention, one for each individual trait. Similarly, document BERT and the multi-trunk BERT also extract the prompt representation for the later use. Finally, both trait-specific essay representation and the prompt embedding are fed into the MOOS framework for scoring. So in this work, MOOS proposed 3 novelties. First, we use the essay as a query. Compared to Protect, use the prompt as a query. It's like evaluating essay from the prompt perspective to determine whether a given essay is likely to receive a high score under the given prompt. But in our work, MOOS use the essay as a query to learn the essay representation, to estimate the distribution of the query essay over the value that is prompt and the essay. Second, we reformulate the task from scoring to cue retrieval. So the motivation is, when training a cross-prompt model, the number of available prompts is extremely limited. If we focus too much on learning essay representation, the model may overfit the same prompt. So to address this, MOOS apply a star gradient operation to the query, so it prevents the representation from being updated during the backpropagation. This fixed query representation serves as a stable anchor for retrieving relevant scoring cues. Third, mixture of order scoring aspect. It's combined two ideas. One is order scoring aspect. We design 3 aspects. Scoring aspect. It evaluates the essay quality. It uses close attention over multi-trait essay feature and additionally include a multi-trait loss. Ranking aspect. It compares the relative quality of essay. It uses pairwise ranking loss to compare the relative quality of multiple essay. Adherence aspect. It measures how well the essay responds to the prompt. It computes the close attention with the essay as query and the prompt as key and value. These 3 aspects work together to simulate how a teacher first score, then compare, and finally check prompt relevance. Next, we focus on how MOOCs select the information for evaluating each trait. So we design mixture of aspect mechanism, which dynamically decide whether to use information from the original essay or the refined feature generated by the scoring aspect. And here, we use the adherence aspect act as the gating function between the 2 aspect network, controlling how much information is passed from each. This dynamic selection allows MOOCs to choose the most relevant scoring queue for each trait. Now let's move on the experiment setup. We evaluate our model on SAP++. It's a widely used benchmark for cross-prompt trait scoring. It includes 8 prompts and covers the 3 essay types: argumentative, response, and narrative. Each essay type is associated with different scoring traits. We adopt the leave 1 prompt out setting, where we train on several prompts and test on the 1 unseen prompt, and we report the QWK on the test set. Compared to the other state-of-the-art, MOOCs achieve the best performance across all prompts and traits. Particularly, MOOCs has the lowest standard deviation and perform especially well on the convention trait. It shows the clearly improvement over the related work. We further analyze the proposed component. As you can see, use the essay as query. It strongly improves the performance since it estimates the distribution of essay over the prompt and essay. We reformulate the task from the scoring to queue retrieval. It makes the model more robust on the unseen prompt. The order aspect to get the best performance on the essay scoring by imitating the human rater from the holistic evaluation to ranking and then prompt adherence. When analyzing the trait-specific scoring, we observed the consistent improvement from the using essay as a query and the order aspect. So here we have one additional finding, that is the effect on aspect ordering. So for the argumentative prompt, the model benefits more from the ranking essay first, since the trait like organization, word choice, they often involve comparing essay. In contrast, for the response prompt, which refer to the source article, it's more effective to score the essay first and then apply ranking later. We visualize on gates of MOE. As you can see, the trait scoring for different prompt type consider the different information. So for example, the narrative prompt prefer the refined feature since the prompt type is open-ended and it requires high-level semantic feature. The response prompt consider the original multi-trait essay feature since it relies on original essay more. So to conclude, in this paper we propose MOOCs. It imitates the human scoring process by evaluating essay's quality, comparing relative quality, and assessing prompt adherence. So we introduce the 3 techniques: essay as query, query detect, and the mixture aspect mechanism. This enables MOOCs to focus on retrieving the most relevant scoring queue for each trait. Our experimental results shows MOOCs achieve the state-of-the-art performance in the trait scoring. It outperformed the previous work, including that built on the large language model. Thank you.